So here's a brief list of the topics that were on paper 1. If you work down the list here, this is how the paper started, and the harder questions being over here. So you might remember that frustum question at the end of the paper. That was difficult to work through, that one. The area of the circle and the pentagon, where you had a smaller circle, the pentagon, and then a larger circle. You had to equate areas. That was quite difficult. If you knew what you do with the transformations of graphs question, that was okay. The arithmetic sequence and series, you do get the formulae on the formula sheet, so you might have picked up some marks there. The vectors question, part A, was you could have got, but part B was very hard. Could have even seen something like that on an A-level paper. The histograms question, the way it was asked, took a bit of thinking about and puzzling through, not really seeing it asked in that way before. The functions question was okay, and the Venn diagrams question, if you knew your notation, for example, n of a dash, so the number of elements not in A, or B union C, you should have been okay on that. And then as we get and go through the first half of the paper, there was plenty on there that was routine, and you should pick up marks and be okay. The HCF LCM, that was a little bit difficult because it wasn't in the whole number form, it was already in the product form. The simultaneous equations was okay. Differentiation, cumulative frequency was okay. The standard form you couldn't do on your calculator, and the indices part of that was quite hard as well. But all in all, I think it was a fair paper, and if you've done an adequate amount of revision and there was enough there of topics that you recognise, you will be absolutely fine. So here's a list of topics that weren't on paper 1, so it's going to be definitely worth having a look at these topics to prepare for paper 2. And what I'm going to do now is go through some questions that are based on this list of topics. First thing I'm going to have a look at is fractions, because you may have been doing a lot of harder topic work and forgotten some of the basic rules, and it's a classic IGCSE question that they'll give you the answer, and it's usually a mixed number, and then they will ask you to show how you got that answer. So for example, if I was asked to do 4 2/3 and divide that by 1 1/9 and asked to show that that equals 4 1/5. So they know that you've got your calculator and you could put that sum in your calculator and get that answer, but you're going to get the marks for the pen and paper method of how you get that answer. So when we're dividing fractions, you're going to think about KFC. That is keep, flip, change. You're going to keep the first fraction, you're going to flip the second one, and you're going to change the sum into a multiply. So before we do any of that though, we have to turn both of these mixed numbers into top heavy. So if you think, if you've got 4 whole ones, how many thirds in every whole one? There's 3 thirds in every whole one. Now if I've got 4 of them, there's going to be 12 thirds, and you get that by timesing those two numbers together. 4 times 3 is 12. 12 thirds would be the 4, but we've got 2 more, so you have to add the top. So that's going to be 14 thirds divided by, doing the same here, 1 times 9 is 9, add the top would be 10 ninths. Now I've got it top heavy, I need to do the KFC, so I need to keep, turn it into a times sum, and then turn that one upside down. Now you can, when you're times in fractions, just times across the top, times across the bottom. But 14 times 9, I don't necessarily know off the top of my head. You're going to cancel either after you've times across the top of the bottom, or you can cancel before you go. And I can see 3 goes into itself once and 3 goes into 9, 3. You always cancel something with on the top with something on the bottom. And then the other diagonal I can see are both even. So 2 goes into 14 7 times, and 2 goes into 10 5 times, and then I can just do the 7 times the 3, 21. 1 times 5 is 5, and 5 goes into 21. If you just got your 5 times table, 5, 10, 15, 20, it goes 4 times, and 1/5 left over. Now what if I was asked to take the same fractions, 4 2/3, and take away 1 1/9? And the answer there is 3 5/9. So they do always give you the answer, and it again is a show that question. So again, we need to turn them top heavy. So that's 14 thirds, take away 10 ninths. Now when we have fractions and we're adding and taking away, we need to have a common denominator. So I can see that the common denominator is going to be 9. So that one I just can leave alone because it's already a 9. So what have I done to get from here to here? I've times by 3. So we need to make equivalent fractions. 14 times 3 is 42. And then once they're in that common denominator, I can just take away the tops. That's going to be 32 over 9. And 9 goes into 32 3 times and 5 remaining. What have I had another times one? 3 1/5 times 2 5/8, and we were asked to show that that equals 8 2/5. So it's another show that question. Turning it top heavy, 3 times 5 is 15, add the top, 16/5 times 2 times 8, 16, add the 5, 21/8. Cancel down, 8 into itself goes once, 8 into 16 goes 2, 2 times 21 is 42, 5 times 1 is 5. Go up your 5 times table, it goes into 48 times, and then we've got 2/5 left over. Going to have a look at surds, whether we're simplifying or rationalizing the denominator. But when you're simplifying surd, you're always looking for underneath the root to be the same as two numbers times together where one of them is a square number. And 45 I can see is 9 times 5, and the 9 is the square number, so you can write that as root 9 times root 5. You can separate them out, and because root 9 is 3, we can just write that as 3 root 5. Now doing the same with the 20, so root 20, if you think of a square number that makes 20, it's 4 times 5. That 4 can come out of the root because it's root 4 times root 5, which is 2 root 5. So altogether we've got 3 root 5 plus 2 root 5. You can just add these like they were algebraic terms. If you had 3a plus 2a, you'd have 5a altogether. We're just collecting root 5s, so that's going to be 5 root 5, and so our k is 5. And the next one, we've got to square this out. So 6 minus root 8. Now when we square, you do not just square both of those. Squaring it means you need to times it by itself. So you write it next to each other, and you're going to multiply out those two brackets. So whatever system you've got for doing that, whether it's crab's claw, smiley face, or foil. So first, outers, inners, last. First is going to be 36. Outers is minus 6 root 8. Inners is that same again because we've got the same bracket, so it's another 6 root 8. And then lasts, a minus times a minus is a plus, and root 8 times root 8 is root 8 squared, and the squaring and rooting will cancel with each other, so you've actually just got 8. And then what we can do is we can just add the numbers. 36 plus 8 is going to be 44, minus 6 lots of root 8 minus another 6 lot is minus 12 root 8. Now they want it in the form of root 2. So again, we can simplify root 8 because we know that 8 is made up of a square number, 4 times 2. That 4 out the root is 2 root 2. So this is going to be 44 minus 12 times 2 root 2. And the 2 can times by the 12 to give us 44 minus 24 root 2 as our answer. Now when we're rationalizing the denominator, what you do is you multiply it by root 2 over root 2. Anything top and bottom the same is going to be 1. So you're timesing this whole question by 1, which does not change the value of the original question, because anything times by 1 is just itself. Now you're going to do that to get on the bottom the root 2 times the root 2, and again, like we had here with the root 8 squared, that's just going to equal 2, and then all we need to do is multiply the 2 by both of those terms in the bracket. So that's going to be root 2 times 10, 10 root 2, and then 3 times root 2 times root 2. The two root 2's times together to give you 2, and 2 times 3 is going to be 6. So altogether we've got 10 root 2 plus 6, and then I can see that both of these terms are even and it's all divided by 2, so that's just going to be half all the top, which we can do because they're even. 5 root 2 plus 3. Now this next one, rationalize the denominator. Because we've got not just a single root on the bottom, we've got a root 2 minus 1. What you need to do here is multiply it by the opposite, the same two things together, but just to change the sign. So it's going to be root 2 plus 1 over root 2 plus 1. Now sometimes on the bottom they're the other way round, and of course you just have these the other way round if you were doing that. So you're doing that to kind of get the difference of two squares effect, because by choosing timesing it top and bottom by something with the opposite sign, when you multiply these two on the bottom, you're going to get root 2 times root 2, which is 2, and then when you do the outers and the inners, because of the different signs, they're going to cancel with each other, so you don't really need to do them because you'll be going up root 2 and down root 2, so they'll both cancel. You just need to do the last, which is the minus 1 times the plus 1, which will give you a minus 1. Now we need to multiply these two on the top, so first will be 4 root 2, outers will be 4, inners root 8 times root 2, we can put them under the same root, which is 8 times 2, which is root 16, which is another 4, and then the last is plus root 8. Now our numbers, we've got 4 plus 4 is going to give me 8 plus 4 root 2 plus root 8. Now root 8, we think about, we've seen this already, is 4 times 2, and then the 4 can come out as a 2 root 2. So that's 2 root 2, and it's all over 1 over the bottom, so we don't need a denominator there. So we have got altogether 8 plus 6 root 2. Next topic is proportion. When things are directly proportional, as one goes up, the other goes up. So for example, if you had table and chairs, if you had 2 chairs for every table, if we had 3 tables, you'd have 6 chairs. So as the number of tables goes up, so does the number of chairs. And there's always a constant of proportionality. And in that example, the constant would be 2, because every time you have a table, you have twice as many chairs. So what you need to do is whenever you see m is directly proportional to p cubed, you write that down as m is equal to k p cubed, and the k, like our times by 2 with our tables and chairs, is our constant of proportionality. Now there's a situation where m is 128 and p is 8. M and P vary like the table and the chairs, but K remains constant. Because we know a situation that already exists, that's going to allow us to find K. So just fill them in. M is 128. 8 cubed is 512, and because we know what that is, we can put that in front of the k. When you're timesing, order doesn't matter. Now to find k, it's joined by a times by 512, so we just can take to the other side to be a divide, and that's equal to k. And if you do that on your calculator, that comes out to be a quarter or 0.25 as a decimal. Now you always have to write the formula, so now we know what k is, that's a constant, so we can write that m is equal to 0.25 p cubed. Okay, so this is the same question. This would be part B when we've already got the formula. Now find m when p is 5. So m and p vary. Our k is the constant. M is equal to 0.25 times 5 cubed. So you've got to do a quarter times 125, and that comes out to give you 31.25. Now, if you're told things are inversely proportional, as one goes up, the other goes down. Now, I see all the time that people write some of these first statements the wrong way round. They'll start with D and put P second. Sometimes they might put root in. If you do not see the word root, don't put a square root. You're just seeing the word square. So when it's inversely, you can write P is equal to K. Now instead of times like we had before, because it's inversely, you've got to put whatever it's inversely proportional to on the bottom. And it's inversely proportional to the square of D. Now we're given some information, and that will allow us again to find K. So 25.6 is equal to K over 1/8 squared. So now to find K, we need to cross multiply, and K is going to be 25.6 times 1/8 squared. So 25.6 times 0.125 squared gives us that K is 2/5 or 0.4. So find a formula. P is equal to 0.4 over D squared. Angles and polygons didn't come up on the first paper, so let's have a look at that. The interior angles on a polygon, there's a formula for that. It's n, the number of sides, take away 2 times 180. That is the sum of the interior. Now, if we had any polygon, say it is a pentagon, the interior angle is here. And if this was regular, we could do 5, take away 2 times 180 to give us 540. And if we wanted to find one of them, we would just divide by 5. And that would give us what one of the interior angles were if it was regular. And to find the exterior angle is not the angle all the way around the outside. It's the angle you turn through to walk around the shape. So if I was walking along this base, I would need to turn through that angle. I'd continue to walk and turn through that angle, continue to walk and turn through that, turn through that, and turn through that. So if I'd gone all the way around this shape, I would make 5 turns, but I would only actually turn 360 degrees. So the sum of exterior angles for any polygon, whether it's got 5 sides, 10 sides, however many, is always equal to 360, and interior plus exterior equals 180 degrees. So in this question, if I'm told that the interior angle of the polygon is 162, work out how many sides. What you need to do is do 180 minus 162 to get 18. And that's equal to the exterior angle. And then if I just do 360 divided by 18, that will give me the number of sides. So that is equal to 20 sides. Now in this next question, we're told we've got a pentagon and an octagon. So because they're regular, all these sides are equal. So I can see because these sides are equal, I've got an isosceles triangle. I'm trying to find out x. So what will help me is to find the interior angles and take them away from 360. Find this angle at the top of my isosceles triangle, and then whatever's left from 180 will be shared equally between those two base angles of the isosceles triangle. So the sum of the interior angles in a pentagon come to 540, and 540 divided by 5 gives me that angle there is 108. The sum of the interior angles in an octagon is going to be 6 times 180, because we need to do this formula, the n minus 2, so 8 minus 2 is 6. 6 times 180 is 1080, divided by 8 to find what one of them is, that's 135. And then if you do 135 plus 108 and take it away from 360, this angle here at B is 117. If you do 180 minus the 117 and divide that by 2, x is going to equal 31.5 degrees. The area of the sector is determined by the angle that makes it. So we've got 84 divided by 360 times the formula for the area of the whole circle, which is pi r squared. So that would be how you would find the area of this sector. And we're told in the question that r is 45. So on your calculator, 84 divided by 360 times pi, we need to do the shift button and pi is down the bottom of your calculator, times 45 squared is equal to 1484.4, and then it asks us to just give it to 3 significant figures, so that would be 1480, and it's going to be in centimeters squared because it's an area. In this next question, we're told that the arc length is 7.2. We haven't got what the radius is, but we're asked to find the area. So what we'll need to do is use the arc length formula. So that is going to be governed by the angle, which is 75 out of 360. Now it's that fraction of the formula for circumference, which is 2 pi r. And we know that the arc length is 7.2, so we need to cross multiply and work out what r is. So you do 7.2 times 360 divided by 75 times 2 times pi, and that's going to give us that r is equal to 5.50039, and then the area of the sector is 75 divided by 360 times pi r squared. Leaving that r on our calculators, we can just square it and times it by pi, times it by 75 and divide by 360. The area is 19.8 centimeters squared. Now we're going to have a look at the circle theorems, and there's 7 that you need to know. So let's just quickly run through them. If you have got the diameter of a circle, then the angle subtended into the semicircle onto the circumference is always going to be 90. So that can be anywhere on the circumference. That is always going to be 90 degrees. If we have a chord, and then if we subtend an angle onto the circumference from the chord, from the same chord, the angles at the circumference, they're going to be equal. So that, some people call that the bow tie. Angles at the center when subtended from the chord is going to be double the angle at the circumference. So if this here at the circumference is x, then the angle at the center is 2x. So some people call that the arrowhead. When you have a tangent meeting a radius, they meet at 90 degrees. What else is there? When you have an external point and 2 tangents meeting externally, then if they meet from A to P and from B to P, then these distances are equal. So AP is equal to BP. If we have a quadrilateral sitting inside, so that all 4 corners are on the circumference, then opposite angles sum to 180. And then if you have a tangent meeting a chord, then the chord divides the circle into a major segment and a minor segment, and the angle between the tangent and the chord in one segment is equal to the angle made in the alternate segment from the same chord. So those two angles are equal. That's the alternate segment theorem. So one of those formulae can come up just on one diagram, or you can have two on one diagram. So let's have a look at a couple of questions. In this question, we're trying to work out ABC, which is going to be this angle here. We can see, always look out for some radius because this is the center O. So when you have a tangent meeting a radius, that's going to be 90 degrees. Now, even though the four corners of this quadrilateral are not inside the circle, it's still a four-sided shape, and the angles inside a four-sided shape add to 360. So because these two corner angles here are both 90, that's half your 360. So this pair here have to go together to make 180. So if we've already got 76 here, then this one's going to be 104. And then we've got the arrowhead with the angle at B going to be half of the 104. So that's going to be 52 degrees. Here's a couple more questions. If we've got A, B, C, D, and all four corners are on the circumference, that means opposite angles are going to sum to 180. So this one here has to be 77 degrees. And then we've got a chord meeting a tangent, and the angle here is in the minor segment, and we've got from the same chord up here, that has to be 39. And then the angle we're after, ADB, is this one here, and then angles in a triangle add to 180. So if we do 180 and take away 39 and take away 77, the angle we're after is 64 degrees. Now in this next one, we've got a bow tie situation. So if we have angles from the same chord going up to 41, then this is 41. Angles coming down from QR, making the 34, then that's also 34. Angles in a triangle, if we find this angle, 41 plus 34 is 75. So this must be 105, which makes this angle here, because we've got a straight line, 75. Now it's asking us to explain why T cannot be the center. If T was the center, we'd have an arrowhead here. So even though we normally have an arrowhead like this, where the arrow is right on top, we can have a situation where you've got your arrowhead like this, and then the one on the circumference is just directly in line. So we've got that situation. If T was the center, then the 41 would have to be half of the 75, and it is not. So T is not the center. Now I'm going to have a look at the intersecting chords theorems. So when you have intersecting chords, they can either intersect inside the circle, like in this first question where they intersect at E, or outside the circle, like in this second question where they intersect at P. But either way, the theorem is the same. Either side of that point of intersection, if we times them together, so 4 times 9 is equal to this pair times together, and it's going to be x times x. So 36 is equal to x squared. So x is equal to the square root of 36. X is equal to 6 centimeters. Now if you apply the same logic when the point is externally outside the circle, it's the point from where the chord starts from the circumference all the way to the point of intersection. So that would be 7 plus 8, 15 times where does D go to meet times 8, and that's going to be equal. Now if we call this point here X, A to B, then it'll be 10 plus X times 10. So 15 times 8 is 120, is equal to 100 plus 10x. So 20 is equal to 10x. So x is equal to 2. In this next question, we've got a travel graph and we've got Jelena leaving home at 10 o'clock. We've got distance and time on our axes. If we wanted to calculate the speed is the gradient of the distance time graph. Now, Jelena has travelled to the park. She stopped at her friend's house, so that's that flat bit on her way to the park. She stayed at the park for 45 minutes. So let's look and see what the time is divided in. 1, 2, 3, 4 small squares make an hour, so each small square is worth 50 minutes, and she stayed for 45 minutes at the park, so that needs to be 3 squares along to represent just staying at the park. She then travelled at a speed of 16 on the way home, so we need to see what time she's going to get home. So you can use the formula triangle that speed is distance over time. Now we know that the speed is 16 for her journey home, and we know that the distance here is 24, and we want to work out the time. So cover that up. Time is equal to distance over speed. So we want to do 24 divided by 16. We can do that on our calculator, or we can cancel that down. It's 3 over 2 or 1.5. So it's going to take her an hour and a half to get home. So that's going to be 4 small squares for an hour plus 2 more for a half an hour. So if we just trace this down, she needs to do 1, 2, 3, 4 for an hour plus 2 more, and then with a ruler you would just join that up. She's going to get home at 2:15. Now you have to really notice what is on the axes. This time we've got speed time. You're always going to get time on your x-axis, but be careful what is on your y-axis. Now we can see the speed starts at 0 and the speed is increasing until we get to 10 meters per second. So look at the units that are being measured in. Now, the rate at which speed is increasing is acceleration. So if we wanted to find the acceleration, it would be the gradient of the speed time graph. Now, we're not being asked the acceleration, we're being asked the distance. And the distance is the area under the speed time graph. So the shape that we have here is a trapezium. You get on the formula sheet that the area of a trapezium is, when you have 2 parallel sides and the distance between them is h, the area is equal to half a plus b h. So we just need to work that out for our trapezium here. It's going to be half. A and b are our 2 parallel sides, and we can see this starts at 5 and ends here at 15, so that's 10. Along the bottom we can see it's 25, so it's going to be 10 plus 25 times the distance between them, which we can see as 10. And if you do that, 10 plus 25 is 35. 35 times 10, 350, and half of that is 175. Now we're trying to find the distance, and we'll use the units. The distance is going to be in meters. Now we've got a change in the subject. So at the moment, y is the subject and we need to make k the subject. So k needs to be on its own and everything else on the other side. Now we can see that this minus belongs to the k. We've got an add of 2m and we've got a square root. Now because that square root goes over all of that sum, if we knew what k was, we'd make it minus, we'd add 2m, we'd take the square root. You need to unravel and do the opposite, work backwards and get k on its own. So the first thing you would do is undo the fact that it's under square root and square both sides, so that y squared would be 2m minus k. Now you want to be finding plus k. So because that minus, it belongs to the k, if we put the k on this side, it'll be plus k, and we want k on its own, so we can just put the y squared on this side. So the 2m is going to stay still. K is equal to 2m minus y squared. If anything changes side of the equal sign, it changes sign. So that would be your answer for 2 marks. The next one, similarly, we've got to make x the subject. X is squared times by q times by 2, make it minus, and then add p. So what we can do is all of this term, because it's those things all times together, they can go to this side. So we can say 2qx squared is equal to p minus y. Then we can do x squared is equal to p minus y all over 2q. And then we can take the square root, so it needs to happen to all of the other side. And that would be what x is. Now, the last one, this is harder because what we're trying to make the subject appears twice, top and bottom. So to make life easier, we're going to have to cross multiply and take all of the m minus 1 term, which is all a divide on this side. If it crosses over the equal side, it's going to be a times. So that's cross multiplying. So you're going to have m minus 1 all times f is equal to 3m plus 4. Now I've got to multiply the m out, so it'll be mf minus f is equal to 3m plus 4. Now the idea is to collect all the m terms together, everything else on the other side. So again, we're going to change sides, change sign. mf minus 3m, because that's coming over the other side. The 4 is staying still, and the minus f is coming over. And then your next move is going to go from having m appearing twice, take it out as a common factor. So it'll be f minus 3 in brackets is equal to the 4 plus f. And then m now only appears once. It's times by all of that bracket. So to undo that times, we're just going to cross multiply and take all of that bracket to the other side. So m will equal 4 plus f divided by f minus 3. Simplifying, you're looking to cancel something down. You can only cancel when things are times together. So I can see I've got an 8 into x minus 4, and on the bottom I've got an x minus 4 times an x minus 4. So x minus 4 in bracket just stands for a number. If we know what x is, it's just that number take away 4, and it's the same number top and bottom, so we can just cancel. So our answer would just be 8 over x minus 4. Now the next one, what you're looking for on the top, you've got the difference of two squares, so that can factorize to x plus 4x minus 4, and on the bottom we're going to try and factorize. So in order to get 2x squared, I need a 2x and an x. In order to get minus 12, I need a plus and a minus. And when I do my outers and inners and the 2 gets involved, I'm going to make 5 in the middle. So if I'm going to have 4 here, because I'm hoping one of these brackets will cancel with 1 on the top. And then when I've got a 4 there to make the 12, I need a 3 there. Now I can see if I go here and go minus, then that will be minus 8x. And here if I put a plus, that will give me plus 3x. So then the plus 3x and the minus 8x will give me the minus 5 in the middle. Now because those two terms are now times together, I can cancel the x minuses 4 and get x plus 4 over 2x plus 3, and that's it. I can't cancel any further. You cannot cancel x like that. You mustn't do that. You can only cancel when things are times between the terms. This is one linear, one quadratic. So what you do here is you use the information from the linear and substitute it into the quadratic. So because my linear has y as the subject, I'm going to write my quadratic as x squared plus, instead of y squared, y is this. So I'm going to say 3x plus 1 all squared, because y has to square, and that equals 5. So now I need to write them next to each other and multiply those two brackets together. So that will be x squared plus 9x squared. The outers is 3x and the inners is 3x, so that will go together to make 6x. And then the last one times 1 is 1 is equal to 5. And then collect like terms. How many x squareds have I got? 10x squared plus 6x bring that 5 over and you'll have minus 4 is equal to 0. These are all even, so I can take a factor of 2 out. Now 5x squared plus 3x minus 2. So 2 times that bracket is only equal 0 if the actual bracket equals 0, because 2 times something is 0 is only going to be 0 when the bracket is 0. So we can divide through by 2. And then we need to factorize again. So 5x and x. 2 and 1, so if I put a 1 there and a 2 there, I need to have a plus 5, so that will give me 5x, and then a minus 2x, and they'll go together to give me the plus 3x. And 2 brackets equal to 0 is only going to happen when 5x minus 2 equals 0 or x plus 1 equals 0. And just solve both sides. 5x will equal to 2. X is equal to 2 over 5 or 0.4. And on this one, x is equal to minus 1. Now I need to go back and find what the y coordinates are. So y in the linear equation is 3 times x plus 1. So y is going to be 3 times 2/5 plus 1, which is 6 over 5 plus 1, which is 1 and 1/5 plus a whole 1, so that's 2 and 1/5. Or when x is minus 1, y will be 3 times minus 1 plus 1, which will be minus 3 plus 1, which is minus 2. So my two places where these are going to meet would be the coordinates if they were plotted. 2/5, 2 and 1/5, they're my x and y pair, or minus 1, minus 2. If Joan invests £6,000 in a savings account, the account pays compound interest 2.4% for the first year. So we need to do £6,000 times 1.024, and that's just for 1 year. And then after that, whatever the answer is to that, we need to times it by the 1.7%, so that's going to be times by 1.017. Now this is the first year. If we want 3 years in total, then this will have to be squared, so that's another 2 years. Now if you just do all that sum together, 6,000 times 1.024 times 1.017 squared, you will get that she will have £6,354.67, and it's just asking us what's the value of her investment, which is all of that. If it said what was the value of her interest, then it would just be the £354.67. Question 36, Tarek buys a laptop. He gets 5% discount off the normal price. He pays 551, work out the normal price. So this is a reverse percentage. He has had 5% taken off. To take 5% off, you times by 0.95 because you think of how much you want left of the original. You want 100% as the original, 5% off is 95%, and that's 0.95 as a decimal. We've paid 551 when we've taken that 5% off. So what we need to do is reverse that and divide by 0.95. So 551 divided by 0.95 is equal to 580. So it was 580 originally. Take 5% off will get us to the 551. This is another reverse percentage. Work out the price of the computer before the VAT. So VAT is being paid at 20%. So somehow we've added 20% on and got £900. So what do you do to add 20% on? You times by 1.2. So to reverse that, we need to do the £900 divided by 1.2. So on your calculators, 900 divided by 1.2 is 750. So the price before the VAT is £750. If you calculate 20% of that and add it on, you will get back to the 900. Next, we've got a probability tree, and the probabilities are already on the branches, but sometimes you get marks just for completing the tree. Always put the probabilities on the tree and the event at the end. So these probabilities are already on, and we're being asked to work out the probability that spinner A lands on 2 and spinner B does not land on a 2. So that's just going through the branches, lands on a 2 for A, which is 1/3, and does not land on a 2 for spinner B. And when you find a route that satisfies what you want through the branches, you multiply. So it's going to be 1/3 times 2/3, which is multiply across the top, multiplies across the bottom, 2/9. In this next question, we've got the probabilities of choosing different snacks for one pupil, and the one that's missing is pasta. Now, because we're told that a student can only choose one, then the probabilities in this row must sum to 1. If you add the 0.35, 0.15 and 0.2, that comes to 0.7, so pasta must make it up to 1 by being 0.3. Now, a student is chosen at random and 300 students use the snack bar on a Tuesday. Work out the estimate of the number of students who chose a pizza. Now, you're going to look at the 0.15, which means 15% of the time pupils or students choose pizzas. So if we've got 300 pupils, it's going to be 15% of them. So you can just do 0.15 times 300, because these probabilities are just for one pupil. So we've got 300, just times it, and that's going to be 45 students. Next, we're going to be solving some quadratics. We can tell we've got a quadratic because we've got an x squared term. Being asked to give our answers to 3 significant figures, that's a big clue that we need to use the quadratic formula. And you look to the front of your exam script on the formula sheet. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. Now write down what a, b and c is. A is the number in front of the x squared, which is 5. B is minus 4, you have to include the signs, and c is minus 3. So feeding them into the quadratic formula. Now, because it's minus b, whatever the sign is on b, you just do the opposite. So that's going to be 4 plus or minus b squared minus 4 squared, minus times a minus will be plus 16, minus, and then put the 4ac in brackets, so it's 4 times 5 times minus 3, because when you times them together, that's going to give you a minus, and then by that minus in the middle, you're going to have minus minus going to make a plus all over 2a, which is 10. So we've got x is equal to 4 plus or minus 16 minus 4 times 5 is 20 times the minus 3 is minus 60 all over 10. X is equal to 4 plus or minus root 76, because this minus and this minus make a plus, all over 10. So that's going to give you 2 answers. X is equal to 4 plus root 76 all over 10. On your calculators, that is 1.27 to 3 significant figures, or X is equal to 4 minus root 76 all over 10, which is equal to minus 0.472. Now the next one, we're being asked to complete the square, but sometimes you might just get asked to put it in this form, and you needed to know that that means complete the square. So when you're completing the square, you look at whatever's in that B position and you half the B. And you're going to do x minus 4 all squared. Then you're going to minus the square of that number there, so it's going to be minus 16, and then bring down what you do want, which is plus 1. And then you're going to tidy up these bits here, so it's going to be x minus 4 all squared, down 16, up 1, which would be minus 15, is equal to 0, and then you just unravel and try and get the x on its own. So x plus 4 all squared is equal to 15. X plus 4 is going to equal plus or minus the square root of 15, and then just take that 4 over. X is equal to minus 4 plus or minus the square root of 15. Next, we're going to have a look at bounds. Now, whenever you're told that a number is rounded to the nearest, whatever it's been rounded to, you half that. So the nearest integer means the nearest whole number. So that's the nearest 1. So half of 1 is going to be a half. So the upper bound is going to be 6.5 and the lower bound for A is going to be 5.5. Now, rounded to the nearest 5, you half whatever this is, which is 2.5. The upper bound is going to be 17.5 and the lower bound is going to be 12.5. Now, we want to find the upper bound for C. If you think about C, it's going to be this takeaway. The B is going to be the 15 and the A is the 6. When we take them away, we want this gap to be at its highest, the upper bound. So we're going to have to use the upper bound for the B and the lower bound for the A to make that gap here the biggest. So we're going to be doing 17.5 minus 5.5, which is equal to 12. Now in this next one, x is equal to 6a over b minus a, and we want again the upper bound. So we want to have on the top the upper bound to get the biggest that we're dividing into, and on the bottom the lower bound. So the A is 3.46 rounded to 3 significant figures, so the upper bound is going to be 3.465 and the lower bound is going to be 3.455. Nearest one decimal place for this one is going to be 6.35 and 6.25. So 6a, we want the upper bound for the A, so that's going to be 6 times 3.465, and we need the biggest, the lower bound this time on the bottom. So we've got b minus a, which is the 6.3 and the 3.46, and we want the gap to be the lowest. So we need the lower bound for the b, which is 6.25, take away the upper bound for the A, which is 3.465. So do that on our calculator. 6 times 3.465 divided by 6.25 minus 3.465. The answer will be 7.464. So they want it to 3 significant figures, 7.46. When you're substituting values into a formula or into an equation, just remember when you put in minus numbers in, put the minus numbers in brackets in your calculator. So if we were plotting a graph and had to get this table, we would put minus 1 in, go in our calculators and do 1 plus 5 times minus 1 minus minus 1 all squared, which would be 1 minus 5 minus another 1, which is just going to be minus 5. And then if you put 1 in, it doesn't matter so much about having brackets, but if you put 1 in, you should get 5. If you put 4 in, you'll get another 5. And if you put 6 in, it again comes out to be minus 5. But you should be able to get those values on your calculator. Just putting the numbers in, but just remember when you put in negative numbers in, use brackets. If you plot a graph, so here we've got the graph of 2x squared plus 3x minus 9, which is plotted here, and then we have an equation and we're being asked to use the graph to solve this equation. When you have an equation, so it's 2x squared plus x minus 4 is equal to 0, that is balanced, so the left hand side is equal to 0, and we can use our skills for balancing equations to make this equation on the left be the same as the graph that's drawn. So my graph is 2x squared plus 3x minus 9. So what can I do to my equation to make it look like the graph that I've drawn? Well, because I can see that I've got 3x, if I add 2x to this side, I need to add 2x to this side, and then I will have my equation. It will still be the same because I've done the same to both sides. Then in the numbers, this is minus 9, so I need to take off 5 to make the equation be the minus 9, and I need to do that on both sides. So if I do this to the left, it will be the same as the graph, but in order to do that on the left, I need to also do the same things on the right. So if I've then got my graph 2x squared plus 3x minus 9, that will equal the 2x minus 5, because if I add those here, I will get my graph, but I need to add them to the other side as well. So the line that I need to draw is the line y is equal to 2x minus 5. So the values of a and b are 2 and minus 5. Now usually the question will go on to then say, plot this line and use this line to solve this equation. So in order to draw that line, it's got a y-intercept of minus 5 and a gradient of 2. So for every 1 along, it's 2 up. 1 along, 2 up. And then if I draw that line with a ruler in the exam, and then where that intersects the curve, if I read up, that will be the solution. Those x values there on the x-axis would be the answer to where 2x squared plus x minus 4 is equal to 0. Now, you're not actually asked to do that in this question, but that's how that sort of question normally goes on to ask you to use the graph to solve. Next, we've got some compound measure formulae. So working out the value of x. The value of x, it's the surface area. So it's just the area of the bottom of this box that needs to go into this formula here. So the pressure is 30. So 30 is equal to the force 27 divided by the area of the bottom of that box, which is 1.2 times x. So we just need to cross multiply. We can take that x up. X is going to equal 27 over, we can leave the 1.2 down there, times the 30. And if you do that on your calculator, x comes out to be 0.75. You could cross multiply all of that and get that 1.2x is equal to 27 over 30. Get that answer and then just divide by the 1.2 and it'll come out to be 0.75, and that will be in centimeters. Question 49, the density is 0.7. We've got our formula triangle that density is mass over volume. We're working out the mass, so the mass is going to be density times volume. So the density is 0.7. The volume is the 3 dimensions times together, so that's 5 times 8 times 12, which comes to 480, and 480 times 0.7 gives us a mass of 336, and we're going to be in grams. When you're converting units that are in 2 dimension, if you think about 1 meter is actually equal to 100 centimeters, but when we're in 2 dimension, if we've got a 1 meter squared, then each length is 100 by 100 if we're in centimeters. So when you times them together to get the area, 1 meter squared is actually 10,000 centimeters squared. So whatever the units are for 1 dimension, we need to double them up. So instead of being 100 centimeters, it's actually 1 and 4 zeros. So that's going to be 10,000. Now we've got to change 12 meters squared to centimeters squared. So all we need to do is times by 10,000. So that will be 120,000 centimeters squared. One last thing, just make sure that you know how to multiply out 3 brackets. So say we had 3 brackets there, you would maybe do 2 of them and then times the other one. So doing the first 2, you're going to get x squared minus x plus 3x, which is plus 2x and then minus 3. So that's the first one. And then multiply by the second one. So multiply x by each of these. So that would be x cubed plus 2x squared minus 3x. And then multiply the 2 in. So that would be plus 2x squared plus 4x minus 6. And then collect like terms, x cubed plus 4x squared plus x minus 6. The other things that I've just seen that were included on the original list, the cosine rule, which you get on the formula sheet, is that a squared is equal to b squared plus c squared minus 2bc cos of a. Just make sure you use that when you have side, angle, side, so a side and an included angle, and that these pair are opposite each other. So angle A is opposite side A. The sine rule, which is a over sine A is equal to b over sine B, which is equal to c over sine C. To use the sine rule, you're looking for pairs of opposites and one missing, and then you can use the sine rule. The area of a triangle is half AB sine C, and again you use that when you have side, angle, side, so the angle included between 2 sides. The other thing I've not had a look at is bearings. Bearings are measured from north and they go clockwise, and if the angle is less than 100, so say this was 70 degrees, you have to have 3 figures. So that's bearings. If you're trying to do a construction, if I was trying to do a perpendicular bisector of this line AB, put your compass in one end, make sure the compass is bigger than half the way the line, and then put your compass, leave them the same width apart, do an arc above and an arc below, put your point in the other side, keeping them the same width, and do an arc above and an arc below, and then join them together, and that will be your perpendicular bisector. If I wanted to bisect an angle, put your point in where the angle is meets, do a mark that is equal distance away from where the angle is made, and then put your compass point in those points, go in the middle, put your compass there, and then join them up, and that will bisect the angle. So have a look at those topics as well before you do the exam. Best of luck to everyone doing the exam on Wednesday.